Hello guys and welcome to the channel. If you're new, drop a like, leave a comment, subscribe if you're new. If you haven't already, you know what to do. And without further ado, let's get into the topic of today's video, which is going to be exponents. So moreover, I want to speak about exponent laws, and I'll go through all of the exponent laws that you guys should know for grade 11 and through about 4 examples, very basic examples, but really crucial in how to apply these laws. So, first exponent law, well, let's just write exponent laws. So, the ones that you guys tend to forget, I really want to reiterate. A to the power 0 is equal to 1. 2. A to the power negative m is equal to 1 over a to the power m, just the same as 1 over a to the power negative m is equal to a to the power m. Third exponent law, a to the power m to the power n is equal to a m times n. Fourth, a to the power n multiplied by a to the power m is equal to a n plus m. A to the power n over a to the power m is equal to a n minus m. 6, a n t m to the power, let's say, q is equal to a n q times t m q, right? So it comes through the commutative and distributive law. And then the new law that you guys are going to learn this year is basically a law that explains the relationship between surds and exponents, or roots and exponents, which is as follows. A to the power n to the root m is equal to a n over m. Now, the way I always remember this is to say, okay, well, a to the power n, right, is to the root m. So what I do is I kind of see this one here, this line, as a fraction divider, and I bring the m to the top, and then when I rewrite it, I just flip it in my mind, and then I flip it on the page. So then it becomes n over m. Pretty easy way to remember it, useful trick to remember it, but unfortunately your exponent laws, even though some of them are quite intuitive, it is something that you're going to have to sit down and remember. You're going to have to study them. So let's look at some examples of how we apply these exponent laws. So, example 1. Say you are asked to simplify something like this. 8 to the power negative 2 over 3. Right? Well, the first thing I would do is I notice the negative, right? So I know that I can go and write it as 1 over 8 to the power negative 2 over 3. Well, not negative, this becomes positive. Then I see, well, okay, 8 is equal to 2 to the power of 3. So then I can go and write it as 1, 2 to the power 3 over 2 over 3. Now I know that these two multiply, which basically means that the 3 and the 3 cancel out. So I can go and rewrite this as 1 over 4, because 2 squared is 4. So simple application of these laws really help you a lot in simplifying equations and these types of simplification problems. So I really urge you to go and sit down and study your exponent laws. Next problem we're going to look at. Say we are given something like the root of 16 plus 8 negative 2 over 3. Right? Root of 16 with the new law we just learned. I know that I can go and rewrite it as well, first of all, let's go and write it as 4 squared, 4 squared plus 8 to the power negative 2 over 3, right? Now, since here's a 2, with the new law we just learned, we know that we can go and write it as 4 to the power 2 over 2 plus 8 to the power negative 2 over 3. And these 2's cancel out, and I'm left with a 4. But I know the 8 I can simplify. I know that I can go and simplify it as such. I know that 8 becomes 2 to the power 3. So it's basically exactly the same as the above example. So now I can simplify it to 1 over 4 plus 4, right? And then if we want to simplify that, well, 4 is equal to 16 over 4. So my simplest answer would be 17 over 4 if I had to simplify this. Again, just simple simplification techniques. Applying your exponent laws correctly, and you can simplify these types of problems pretty easily. With that said, let's look at another example. Say we are given something like x just another one for good luck. And again, we are asked to simplify this problem. Now this could be quite a tricky problem, but it doesn't have to be. So you could go a long route of doing this by going and writing this as, well, okay, say for example the first root here, so I'm not going to write the whole thing out, we're just referring to this part. We can go and rewrite that as x multiplied by x to the power of a half, right? So then that just becomes 1 plus a half, which is 3 over 2 at the end. But what you could do is, there's a law which I haven't really seen in any textbooks, well, at least not when I was in school, that says that I can do this. So right, because these two are the same, I have an x and an x, right? I can go and rewrite it as x m times n. Now this is exactly what I can go and do here, right? Now these are all root 2, just the square root. So I know that in front here is a 2. So if I multiply all these 2's, which is 1, 2, 3, 4, right, I'd get 8. So I can write that as x square root of 8x, right? And then all I have to do is, I know that this is to the power 1, basically, and I can go and rewrite it as such. X times x to the power 1 over 8, which is basically x1 plus 8, which is equal to 1 over 8, which is equal to 9 over 8 x to the power 9 over 8. And that is really a very, very, very efficient way of doing it. Very simple, very, very efficient. And I really urge you guys to remember this law in particular, because it might be very useful, especially during an exam, which is a typical question that you might get that requires you to think outside of the box. So I've eliminated the box for you guys and given you a shortcut to solving this type of problem. If you didn't know this law, well, congratulations, you know it now. And that is it for this video. Really hope you guys enjoyed the video. Hope you guys found it useful, entertaining, and educational. If you liked it, please do like the video, comment, subscribe if you haven't already, and that is it for this video.